everyone, Ms. Sundberg. I am coming to you today to talk to you about mole-to-mole reactions. What we're going to be learning today is when we start with moles of one chemical, and then we switch to moles of a new chemical. And we do that by using what's called a mole ratio, or moles over moles. And we use the coefficients from the balanced chemical formula for this step. So we are going to start here with this problem right here. Your assignment is going to be pages 2 and 3, the second page 2 and 3. And so we're going to be looking at mole-to-mole ratios. So something really important that you're going to want to do when you're doing this is to note which chemical you're using, chemical A, and which chemical you're starting with. That's chemical A, and which chemical you go to is chemical B. So in here it says we have 4 moles of NH3. Since NH3 is the one that's listed, I'm going to label that as chemical A, and it wants me to go to how many moles of H2O. That will be my chemical B. So just like on that mole roadmap where I have right here, I'm going to take a screenshot of that. And we'll come back down to this. And I'm going to insert from the photo library this little picture I just took, so I don't have to keep going back and forth to that. So here's my little picture I just took. Make that a little smaller. Move it right over here. And so what I hope you're noticing here is that we're starting here with moles of A. So A is going to be on the bottom and B will be on the top. So A will be on the bottom and B will be on top. Well, my A chemical I know is NH3. And so I look in my balanced chemical reaction and I find where NH3 is. The 2 that goes with it is going to be my moles, NH3. And then my B chemical is H2O. So I look in my balanced chemical reaction and I find H2O. The 3 that goes with it is going to be my 3 moles of H2O. So now I just solve because mole of NH3 cancels with mole of NH3. So I have 4 times 3, which is 12, divided by 2, which is 6. 6 moles of H2O. There you go. All right, next. This one's a little harder because I didn't balance the reaction for you. All right, so make sure you divide. List all of the elements that you have going on each side. I have on my reactant side, I have 2 NAs, I have 2 S's, I have 3 O's, and I have 2 I's. Over here, I have 1 Na, 1 I. Ooh, but I also have an Na right there. So I have 1 Na here plus 2 NAs there for a total of 3 NAs. Weird. S's, I have a total of 4. O's, I have 6. And I's, I have 1. Wow, this equation is really not balanced. But here's what I notice. I notice a 4 and 2. I can get this S to a 4 really easy. And I can get this O to a 6 really easy because both of these are multiples of 2. Like if I were to multiply 2 times 2, I would get 4, and 3 times 2, I would get 6. So let's try to increase this side by a 2. So if I put a 2 there, that 2 is going to make my Na now 4, my S's now 4, and my O's now 6. Okay. Now let's get my I's. I have 2 I's here, and I have 1 I here. So let's fix my I's. If I go up here, I am going to need to put a 2 there. That 2 goes to everything behind it. So now that 2 is going to give me 2 NAs here, plus the 2 here, for a total of 4. And that 2 goes just to the I for a total of 2. There we go. Now I'm balanced. Now you're going to want to erase some of this and make some room for your mole reaction. Again, the first element that you're given is going to be your chemical A. So 21.4 moles of sodium iodine. That will be my A. Now I need to move this guy because it's in the way of my question here. And then it wants to know how many moles of iodine. That will be my B. And this will be my A. All right, so write down my given, 21.4 moles of sodium iodine. I know sodium is Na and iodine is I. I look up here, I find NaI. That's in my equation, so that's good. I'm going to set up my brackets just like that. Remember, looking here, chemical A goes on the bottom, chemical B goes on the top. Chemical A is NaI, sodium iodine, NaI. In the formula, NaI is right here, so I would have 2 moles of NaI. Okay, I can erase that A if that's confusing for you to be there. I'll move this in here. And then what goes on top, if you look here, is moles of B. There's my moles of B. So my moles of B, and in this case, our B chemical is iodine. Iodine is right there, I2. So I'll erase B and I will write I2. I notice there's no coefficient in the front, so I assume it's a 1. And now I just solve. I take my 21.4 times 1, don't really need to do that, then I divide by 2. And I end up with 10.7 moles of I2. Simple enough. All right, so hopefully at this point you guys are learning that you need to multiply by moles of A on the bottom and moles of B on the top. And as these problems get harder, you're going to see where now, oh my gosh, you need to crisscross charges. And then, oh my gosh, you need a balance. And then you're going to start with moles of sodium oxide. That will be your A. And then you have to go to sodium fluoride. That will be your B. Okay, it gets a little harder. Now I have to predict the products. Okay, so I have an element plus an element. I'm going to get a compound. Okay, or I have A plus B is going to give me AB. All the stuff that you guys have been learning all year is coming back to you, right? So you're going to have to predict the products. You're going to have to know that this is element A, chlorine. That's my first chemical. And it wants to know how many products. That's going to be my B chemical, whatever my product is. Don't forget to crisscross charges on your product. Down here, again, you have to predict your product. You have to crisscross charges. Don't forget diatomics, okay? So good luck on this. I hope this helps. If you need help, please see Brewer or I. We're always available to answer any questions, okay? Bye, everyone.